Okay, students, welcome back. Good evening for the third session of today's webinar series, where finally we come with the chemistry webinar series live. I do not need to give you an introduction as because you have already seen Helen ma'am, the common grace from yesterday on. You are seeing she is introducing all of us, but today I have the golden opportunity to introduce her finally. She will be your mentor and educator of for the subject chemistry. Like me, you have seen me disturbing you all yesterday. Today she will take the session and it will be an enthralling session. So please buckle up your seats to learn something from Dr. Helen. Ma'am, the platform is yours.
Thank you, Sonia. Thank you. Okay. So, students, today our topic is solution. Solution is a very bit difficult. Actually, you feel it difficult, but it is actually not. Okay. So, what is solution? First, we have to know. Solution has two parts. One is solute, another is solvent. Okay. And from class 10, we know that we have three types of solution. True solution, colloid, and suspension. So here we will deal mostly with true solution. True solution means where the solute dissolves in solvent. That is called true solution. So for that, the chapter solution, actually this solution chapter covers both CBSE 12 and ISC, and its weightage nearly minimum 3 marks to 5-6 marks. It has a very significant numerical portions, and the numericals are very easy. If you know the chapter, if your concept is clear, then you can do the numerical like this. Okay, so here is the chapter. So solution. What we learn today? We will learn today first strength of solution. That is the different concentration parameter of the solution. Next, we learn the colligative properties. I will explain all the topic. Okay. Next, abnormal colligative property, then ideal solution, and then some question answer based on conceptual and PYQ related. Okay. So first, what is the strength of solution? This is very, very important. From class 11, you are learning this. And from class 11, I have seen that all the students have this problem remains. किसी का कॉन्सेप्ट क्लियर नहीं होता है, किसी का नॉर्मलिटी क्लियर हो जाता है तो मोलैरिटी में प्रॉब्लम होता है, मोलैरिटी क्लियर हो जाती है तो मोलैरिटी में प्रॉब्लम, मतलब हर दिस टॉपिक में प्रॉब्लम ही रह जाता है. तो प्लीज टेक अ स्क्रीनशॉट एट फर्स्ट. इट्स माय एडवाइस टू यू. Okay. Now, first, what is normality? So, this is normality. Normality means in 1000 ml solution, the number of gram equivalent weight of solute present in it. That is called normality of the solution. Okay, now what is gram equivalent? This concept should be very clear. Okay. What is gram equivalent? For that, you have to know what is equivalent weight. Mostly, lots of formulas for equivalent weights are there. Okay, and it needs another a whole class. For our today's topic, जितना जरूरी मैं उतना ही तुम लोगों को डिस्क्राइब कर रही हूँ. ठीक है. What is equivalent weight? For acid, base and salt, we will discuss about these three things. Okay. For acid, equivalent weight को हम लोग E से denote करते हैं. It is denoted by E. Now for acid, molecular weight divided by replaceable number of hydrogen or basicity of the acid. Okay. किसी भी एसिड में जितना नंबर ऑफ रिप्लेसेबल हाइड्रोजन होता है, सोचो कि जैसे कि H2SO4, two hydrogens are there and these two hydrogens can be replaced by any active metal or anything. Okay, electropositive things. So these two hydrogens are replaceable and this is known as the basicity of the acid. Just the reverse, basicity of acid. So that is molecular weight divided by number of replaceable hydrogen atoms. Okay, so that is equivalent weight for acid. For example, जैसे मैंने बोला कि for H2SO4 molecular weight of H2SO4 divided by 2. ठीक है, so this is the equivalent weight of acid. Now what is equivalent weight of base? Now for base, same molecular weight divided by replaceable number of OH, that is the acidity of the base. Just reverse, acidity of the base. Okay, as for example, aluminium hydroxide, formula is AlOH whole thrice, then the replaceable OH will be 3, then the molecular weight three. Clear? Now the equivalent weight of salt, acid, base and salt. So for salt, it is molecular weight divided by total number of cation into charge or total number of anion into charge. What we know, if the salt is, for example, NaCl, fine, okay. The cation is sodium having +1 charge, that means 1 into +1 for cationic portion. For anionic portion, it is 1 into -1. Okay, so the product in both the way are same, the number is same, the sign is reversed. Okay, we take the mod value irrespective of sign. Fine. So we will write here the mod of total number of cation into charge. Okay, so this is the equivalent weight of salt. So acid, molecular weight by replaceable number of hydrogen, base, molecular weight divided by replaceable number of OH, salt, molecular weight divided by number of total cation into charge within mod. So this is the equivalent weight. So mostly we will deal with the salt. So we have to know this equivalent weight of the salt, how to calculate. So we now you know that is very clear to you, hopefully. So when in 1000 ml of solution, if a given weight is there, then how you can calculate the normality? For normality calculation, you can do one thing. You just first you calculate the equivalent weight of the salt. Really very sorry. Today my voice is not okay. So first you have to step by step. Okay. First you have to calculate the molecular weight. Then you calculate the equivalent weight. Then you calculate the given weight, which is in 1000 ml solution. That given weight divided by equivalent weight. Then you get the normality of the solution. And remember it, always it's in 1000 ml solution or 1 liter of solution. Okay, so normality, hopefully it's clear now. Next is molarity, that is denoted by capital M. Now what is molarity? Again the same thing, in 1000 ml solution, the solution parameter is same. 1000 ml solution, 1 mole solute is there. Okay, the mole concept is since from class 10, hopefully everyone know that. Mole is the given weight divided by molecular weight. That is the number of mole. For this chapter, only this formula is required. No other formula, because there is also another lots of formula regarding mole calculation. Okay, because we know I'm just sharing with you, 1 mole is equivalent with 1 molecular weight. is equivalent with Avogadro number of molecules, equivalent with 22.4 liter of gas at STP, है ना? ये याद आया? क्लास 10 में हम लोग सब पढ़ते हैं इसको कि मोल के साथ सबका इंटर रिलेशन इन टर्म्स ऑफ वेट, इन टर्म्स ऑफ नंबर ऑफ मॉलिक्यूल्स, इन टर्म्स ऑफ वॉल्यूम. ओके, so this is the molarity of the solution. Okay, next is formality. Formality is not like that formality, it's actually for strong electrolyte salts, because strong salts जैसे कि सोडियम क्लोराइड ये ऐसे Na प्लस और Cl माइनस करके नहीं रहते हैं. ये कैसे रहते हैं? ये लैटिस में रहते हैं, है ना? सो इन दैट लैटिस इट्स कोऑर्डिनेशन, अरेंजमेंट, ये सब कैलकुलेट करके हम लोग क्या करते हैं इन सॉलिड स्टेट. जब भी तुम लोग लर्न करोगे सॉलिड स्टेट, अभी तो ये सिलेबस में नहीं है, इसको रिमूव कर दिया गया है. तो पहले ये क्लास 12 में था. तो सॉलिड स्टेट में क्या होता है, Na प्लस एंड Cl माइनस का वो कोऑर्डिनेशन जो होता है वो कैलकुलेट करके Na प्लस इज टू Cl माइनस का एक रेशियो आता है. ओके, एंड जनरली इट कम्स 1:1. सो उस हिसाब से इसका मॉलिक्यूलर वेट कैलकुलेट किया जाता है. तो दैट इज नोन एज फॉर्मूला वेट, एंड दिस इज स्टैंड्स फॉर, this one stands for strong electrolyte solute, and this is not in our syllabus. Sorry. This one, formality, not molality. Next, molality. Molality is very important. This is actually required in our chapter. अब तक हम लोग क्या कर रहे थे? In 1000 ml solution. In case of molality, it is in 1000 gram solvent. How many number of moles solutes are there? 1000 gram solvent, इसमें कितना number of mole of solute है? That is known as molality. Molality is very, very, very important for this chapter. Again, I am repeating you, in 1000 gram of solvent, how many moles of solute are there? Okay, and it is expressed in small m. Okay, next is percent strength. This is also very important. Percent strength में क्या होता है? So X%. There are three types of percent strength. Okay, W by W, W by V, V by V. Okay, so X% अगर W by W लिखा है, okay, that means एक gram solute in 100 gram of solution. Okay, if X% W by V is written, that means X gram solute in 100 ml solution. If X% V by V लिखा हुआ है, that means X ml of solute in 100 ml of solution. Okay, that means this is the first term. This first term stands for solute, and this one stands for solvent. Okay, the phase, actually the phase, whether it is in volume or whether it is in gram. Okay, so percent strength is denoted in this X% W by W, W by V, V by V. Okay, next, ppm, parts per million. It is also required in hardness of water calculation, which was earlier in class 11 in hydrogen chapter. Now, no, it's not in your syllabus. Okay, I'm telling you because it can be used your entrance purpose. Parts per million. The name defines it. The amount of solute present in 10 to the power 6 part of solution. That is known, you know now what is million? 10 to the power 6. So 10 to the power 6 part solution में कितना amount of solute है? That is known as parts per million. So this is also not needed in this chapter. But next, so for this chapter we need normality, molarity. mostly molality, percent strength, and now this one is very important, mole fraction. So what is mole fraction? Mole fraction is denoted by X. Okay. Mole fraction means number. This is the solution, so we can say in terms of solute and solvent. Okay. Okay. Mole fraction of number of solute divided by number of solute. Sorry, number of mole actually. Number of moles of solute. Number of moles of solute plus number of moles of solvent. Okay, that is mole fraction of solute. Mole fraction of solute. Okay, this is mole fraction of solute. Similarly, for solvent, in the numerator there will be number of moles of solvent divided by number of moles of solute plus number of moles of solvent. Okay, so these all are the parameters of calculation for strength of solution. That is the concentration. How can you define the strength or the concentration of the solution? Okay, so our mostly very important, again I am telling you, the molality, okay, then the percent strength, then the mole fraction. Okay, molality, percent strength, mole fraction for this chapter. Okay, what I am telling you, follow this, you will get result in your boards. Okay, बार बार मैं नहीं आऊंगी, एक ही बार बोलूंगी, please follow. Okay, so now the very important question, can you tell me among normality, molarity and molality, which one is temperature independent? I am waiting for 1 minute. Please tell me. Normality, molarity and molality, which one is temperature? Which one is temperature independent? Yeah. Okay. Hopefully you got the answer. Someone is commented in WhatsApp. Please comment in our YouTube channel, inbox us there. Okay. The answer is molality. Okay. Because what I have defined all of them. In case of normality, this is volume. In case of molarity, this is also volume. But what about this? This is gram, that is mass. This cannot be changed with temperature. So molality is independent of temperature. This is very important question for board. Among normality, molality, which strength is independent of temperature? Okay. So we are going to our next topic. So strength of solution done. Next is our two laws, Henry's law and Raoult's law. What is the difference between these two laws? The basic difference in these two laws, Henry's law helps us to understand the solubility of a gas in a liquid, and Raoult's law helps us to understand the liquid-liquid miscibility. Okay, maybe they are very much miscible, maybe they are immiscible, or their interactions are less or high. So first we have to know the what is Henry's law. In case of okay, you can see this is vapor pressure of the solution. Okay, this is Henry's law constant, and this is mole fraction of the solute, that is the gas. Okay, so this is vapor pressure of the solution. This is Henry's law constant, and that is the mole fraction of solute. That means actually this is the final derivation of the law. In this law, there are different types of statements. Oh, okay, for exam tips, all statements you have to learn what is written in any standard book which you are following, word by word. Okay, you can understand in any language in any words, but you have to write the proper words. For that, you have to learn books of your choice. We have no choice. We are not recommending any book. Please go through any book which you like, but please do study a book. ओके तो हेनरीज लॉ में क्या होता है एक्चुअली बोला जाता है कि कोई भी गैस व्हेन इट इज सॉल्युबल इन अ लिक्विड इट डिपेंड्स अपॉन टू फैक्टर्स one is pressure another is temperature okay when you are increasing the temperature the solubility is decreasing this is inversely proportional and pressure के साथ ये एकदम directly proportional होता है जैसे वो हम लोग करते हैं ना जैसे कोई कोल्ड ड्रिंक्स का बॉटल बोलते हैं ना शेक करके मत उसको ओपन करो दिस द मेन रीजन बिकॉज इट इज उसमें क्या रहता है प्रेशर रहता है जितना तुम उसको शेक करोगे उसका प्रेशर क्या होगा जब भी तुम उसको ओपन करोगे उसका प्रेशर अचानक से रिलीज होगा तो दैट विल एक्सपैंड जो डिजॉल्व गैस होता है ना उसमें CO2 दैट विल एक्सपैंड एंड इट विल कम आउट विद द वाटर ड्रॉपलेट ओके सो दैट इज द that all the things summarized in this Henry's law. So this law is applicable for solubility of a gas in a liquid. Okay? Okay? Next is Raoult's law. Raoult's law in this chapter we have lots of Raoult's law. Okay. So Raoult's law में क्या होता है? Liquid miscibility. Fine. So first we will go to the solution when two liquids are actually before going into Raoult's law, we have to understand the concept of ideal solution and non-ideal solution. Okay. So what is ideal solution? For ideal solution, delta H mixing and delta V mixing is 0. That means when two liquids are mixed together, for example, A and B, definitely this should be non-reactive. Okay. When A and B are mixing together and their volume remains same, for example, 10 ml A, 10 ml B, when they are mixing together to form 20 ml AB solution, A and B ka solution. So that is called delta V mixing 0. And while they are mixing together, there is no temperature releasing or no exothermic or endothermic process. No heat is exchanging with the surrounding. So that is called delta H mixing 0. Okay, that is for ideal solution. Now, what is non-ideal solution? In case of non-ideal solution, definitely these two parameters are not 0. Okay. Now, what are this type of non-ideal solutions? there are two types of non-ideal solutions. Okay, at first I draw something for you. Okay, so this is for ideal solution. When there is only x, no b is there, so vapor pressure is like that. It is, sorry, this is for a, it has some definite value. When only a is there and gradually a is decreasing, its value is decreasing when it's in pure state. Okay, so the formula is Pa is equal to Pa naught into Xa. That is for our solution or for liquid A. Now what is Pa? Pa is the vapor pressure of the solution of pure liquid when it's in as single component. And what is Pa0? Uh, Actually, whenever in this chapter there is any term 0 in power, okay, that is for pure form. In solution chapter, if there is any 0 in power, that means that parameters defines as the purest form. Okay, so Pa naught means that is the vapor pressure of the pure A liquid and X is the mole fraction. Now this is where XB is there, it is not there. Okay, so this is, and gradually this is decreasing same like before, and the equation will be Pb is equal to Pb0 into Xb. Fine. And when these two liquids combine together, this gives a solution which is called ideal solution. And for that ideal solution, we have this equation. This P actually is for solution. This P actually is for solution. Okay. And this is Pa plus Pb. Fine. Partial vapor pressure of that liquid A in solution, vapor pressure of liquid B in solution. Okay, both the, that means for ideal solution, this equation is very important, very important. Okay, this is for ideal solution. Please have screenshot for it. This is very important. This is ideal solution का vapor pressure का equation है. That is the both the component का. Okay. अभी इस ideal solution का जो vapor phase है, उसमें जो mole fraction होता है, that is also very important. Okay. वो कैसे किया जाता है? हम लोग उसको y से डिनोट करते हैं. ठीक है, वेपर फेज में मोल फ्रैक्शन ऑफ द कंपोनेंट इज डिनोटेड बाय y. y is denoting here mole fraction in vapor phase. Okay, so now the formula for ya for component A का मोल फ्रैक्शन इन वेपर फेज में क्या होगा? इज इक्वल टू Pa नॉट A divided by P solution. Okay. Simultaneously B के लिए क्या होगा? PB not XB by P solution. These equations for ideal solution is very important. If you want, have a screenshot for it. Okay. Now we are going to the non-ideal solution. What are those? If the component A and B have interaction, what will happen? Will they want to go to the vapor phase? No, they will not. They want to be stay in the interacted position. That means if we are taking the example of HCl and water. HCl and water, what is that? HCl is ion. In water, it will be in an interaction, ionic interaction, hydrogen bond interaction, lots of interactions are there. So when HCl is a component, water is a component, A and B, and these two are miscible. And when they have interaction, so they will not try to go in the vapor phase. So vapor pressure will be less, and for that negative deviation will be occurred. Okay. So for negative deviations, the lines will be like this. The same for ideal gas, and put down here. This is the negative deviation. Negative means come. Yeah, niche na. That's why the negative deviations are there. Okay, that is when the two elements are two liquids are interacting with each other, and they do not want to go into the vapor phase. Okay, when they have least interaction. And what about the पॉजिटिव डेविएशन? पॉजिटिव डेविएशन तब होगा जब दोनों में इंटरेक्शन कुछ खास नहीं है, जैसे कि अल्कोहल एंड वाटर, उस दोनों में कुछ इंटरेक्शन उतना खास नहीं. Ionic interactions are not there. Hydrogen bonds are there, but still, so there will be positive interaction and no positive interaction. There will be positive deviation. Okay. मैं एक ही ग्राफ में दिखा रही हूँ. You will get this diagram in books also. Okay, for ideal solution, for non-ideal में positive deviation and negative deviation. Again, the red lines are showing you the ideal. The yellow ones are for the negative deviation and the green ones are for the positive deviation. Okay. So बहुत अच्छी तरीके से ये सब पढ़ लेना. Okay, क्या difference between ideal and non-ideal solution? हाँ? और what is the basic difference between Henry's law and Raoult's law? ठीक है. In case of Henry's law, we are dealing with the gas in solubility of gas in liquid, or in the Raoult's law, we are dealing with the liquid miscibility. Okay. So hopefully these all topics are covered now. In case of Raoult's law, this is the formula. This is the vapor pressure of the solution of a component is equal to mole fraction, and again that's zero. Whenever there is power means zero, that means that is for the purest form. That is for the purest form. Okay. So this portion hopefully is clear to you now. Again, I am repeating Henry's law, Raoult's law, ideal solution concept, non-ideal. In non-ideal, में positive deviation, negative deviation. Okay, next slide. Now, here are two MCQs for you. Please, you solve it and please comment in YouTube channel. It's live ना, सबको पता तो होना चाहिए. ठीक है? Don't do in WhatsApp. Okay? Please. I am coming back within 2 minutes. Come on, we are here for this question solution. Actually, these are for CBSE 2023 and this is for CBSE All India Term 1 2022. These questions are very important. So please, hopefully you got the answer. Actually, what is the question? The first one is assertion reasoning. In this, first the assertion is the enthalpy of mixing is equal to 0 for an ideal solution. That is so correct. I have told you earlier. The next one, for an ideal solution, the interaction between solute and solvent molecules is stronger than the interaction between solute or solvent molecules. What do you think? This is correct. Oh, there is no change in interaction. This is ideal solution. बाबा कैसे होगा? Ideal है तो कुछ अलग नहीं है इसमें, सब equal है. Okay. So the option क्या है? Our assertion is true, but the reason is wrong. So what is the option? A is true, but R is false. C. Okay. Okay. The next one. Oh God, what is this? Azeotropic solution. Do you know that? What is azeotropic solution? Have you ever heard? Have you ever heard कि in laboratory we are getting 68% nitric acid, not more than that concentrated. We get 95% alcohol, not more than concentrated. 5% water ko we cannot expel out. 32% water from nitric acid we cannot expel out. Why? Because those solution are azeotropic solution. That is called constant boiling mixture. What is that constant boiling mixture? मतलब एक जगह आता है, पहले अगर तुम किसी को डिस्टिलेशन करके और सेपरेटिंग आउट टू सॉल्यूशंस. ओके फाइन. सो इनिशियली जिसका बॉइलिंग पॉइंट लो है that will come out and the temperature remain fixed. We know for phase change the temperature is fixed. Then क्या होता है? Temperature increases for the second one. तो तब जाके क्या होगा? सेकेंड वन निकलेगा. सो ये दैट इज फ्रैक्शनल डिस्टिलेशन. एक एक फ्रैक्शन में एक एक निकलता है. ओके, डिस्टिल आउट होता है. But when there are only two components, distillating out only one and one other one is remaining there. Okay. So when you are doing that at a particular composition में जाके क्या होता है? When you are giving temperature to it, both components are coming out. Whenever मतलब जैसे कि nitric acid beyond 68% composition, when if you want to try 69%, 70%, it cannot possible, because when it reaches 68% and you are hitting the solution, that 68% and 32% water composition both are coming out. That is called azeotropic mixture. Okay. Now there are two inputs for you. Whenever the two components interactions are very high, that means negative deviation of the from the ideal solution, and that two component will form maximum boiling mixture. Okay, and for the other one the minimum one. Okay, so an azeotropic solution of two liquid has a boiling point lower than either of two when it. Okay, मैंने अभी क्या बोला? अगर इंटरेक्शन खूब ज्यादा होता है, मतलब जब नेगेटिव डेविएशन होगा तब क्या होगा? ज्यादा होगा बॉइलिंग, है ना. और जब क्या होगा? इंटरेक्शन ज्यादा होगा, मतलब पॉजिटिव डेविएशन होगा, तब जाके क्या होगा कि पॉजिटिव डेविएशन के लिए लिक्विड का जो एजियोट्रोपिक मिक्सचर होगा उसका बॉइलिंग पॉइंट लो होगा. क्लियर है? तो फिर हम लोग का ऑप्शन है ए करेक्ट. ठीक है. ओके, फॉर नेक्स्ट वन. This is the main actually heart of the solution topic, that is the colligative properties. What are the colligative properties? At first you have to know. The colligative properties actually this is for solute only, and this is based only on the number of particles present in a solute, number of particles of solute present in a solution. That controls all these properties. That is called colligative properties. This does not depend upon the nature of the solute or nothing else, whether it is electrolyte, non-electrolyte, covalent, organic, inorganic, ionic, nothing. The number of particles present from that solute depends on it. Okay. So What are these colligative properties? So, oh, I have to write. The colligative properties depends the number of particles of solute present in solution. Okay. So these are the colligative properties. What are those? First one is relative lowering of vapor pressure. Second one is elevation in boiling point. Third one is depression in freezing point. And fourth one is osmotic pressure. Okay. Now we are going to the first topic. What is relative lowering of vapor pressure? So at first you have to know what is vapor pressure. What is vapor pressure? Actually वेपर जो प्रेशर एक्सर्ट करता है वो है वेपर प्रेशर नहीं. एक्चुअली क्या होता है, is very interesting. In a closed container, okay, there is liquid, and you know na evaporation from the surface, the molecules are going to the vapor phase. Same here. Listen, vapor. Okay, the liquid from the surface it is going to the vapor phase. So a time will come when the vapor will condense together. So initially liquid to vapor. After reaching certain concentration of the vapor, there will be a time when vapor will condense and get back to the liquid. Okay, so liquid is going and vapor is again coming down as liquid. So there will be two rates, liquid to vapor, vapor to liquid. Time will come when both the rates are equal. When जितना amount of liquid vapor में जाएगा उतना amount of vapor ही liquid में back करेगा. Okay, this is called equilibrium. Mind it, it's in closed container. Okay, it cannot be possible in open one because the vapor will evaporate out. Okay. So it's in closed container. So at this equilibrium, definition को थोड़ा follow करना हाँ. At this equilibrium, when the rate of liquid to vapor and vapor to liquid are equal, that condition वो vapor surface के ऊपर, liquid surface के ऊपर at that temperature जो pressure exert करेगा, that is called vapor pressure of that liquid. Okay, that is called vapor pressure of that liquid. So this is our vapor pressure. Now what happens, पहले जो हम लोग पढ़े थे जो solution के लिए वो क्या था, for volatile solute we are adding, or volatile liquid actually we are adding to the solvent. Raoult's law. Now क्या हो रहा है कि we are adding non volatile solute in the solvent. Again इन पहले का जो Raoult's law हमने पढ़ा था उसमें क्या था, उसमें था volatile portion of solute, volatile solute. इसमें क्या है, non volatile. Non volatile means it will remain with the solvent in the solution system. So these blue dots are actually the solvent. It's a closed container. Okay, it's a solvent, and the red between them are the solute. Non-volatile solute we are adding. Okay. So अभी देखो पहले क्या था, खाली एकदम pure solvent था. All the solvent molecules are on the surface. Now क्या है, उसमें थोड़ा थोड़ा मैंने तो ऐसे draw किया roughly, but actually क्या होता है, numerous molecule of solutes are at the surface. सो पहले जितना सॉल्वेंट ऑफ मॉलिक्यूल्स ऑफ सॉल्वेंट वो सरफेस से ऊपर जाना चाह रहा था, अभी उतना नहीं जा पाएगा क्योंकि उसकी जगह क्या है, थोड़ा थोड़ा सॉलिड मॉलिक्यूल्स आर देयर. तो वेपर का कंसंट्रेशन विल डिक्रीज and gradually vapor ka pressure will also decrease. That is called relative lowering of vapor pressure. Lowering of vapor pressure to clear hai. Now why relative? Because it is compared with the pure solvent. हमेशा solvent के साथ ही comparison होगा. Relative lowering of vapor pressure. Relative means it is compared with the pure solvent, and lowering means when you are adding non-volatile solute with the solvent. अब क्या होगा? Vapor pressure will decrease. Fine. So फिर क्या होगा, ये हम लोगों का आ जाएगा राउल्स का लॉ. फॉर रिलेटिव लोअरिंग ऑफ वेपर प्रेशर वी हैव टू लर्न राउल्स लॉ. ओके, दिस इज द लॉ. क्या है इस लॉ में? इस लॉ में क्या है? पी नॉट माइनस पी. इसको थोड़ा और सिंप्लीफाई करके मैं बता रही हूँ. पी नॉट, अगेन द नॉट, द पावर में जीरो. क्यों है ये? दिस इज फॉर प्योर सॉल्वेंट माइनस पी एस. एस फॉर सोल्यूशन, सोल्यूशन का वेपर प्रेशर, divided by again P naught with the pure solvent. This is equal to X. Now why this 2? Before going to the chapter, I should inform you that thing. For this chapter, whenever any prefix come 1, A, that means for solvent. Okay? And whenever any prefix come like 2 or B, that is for solute. Please have screenshot for it. Don't get confused. Whenever any parameters having prefix 1 or A, that means that is for solvent. And whenever any prefix for 2 or B, that is for solute. Okay. So, that X2 stands for the mole fraction of the solute. Mole fraction of the solute. Let's simplify it. Okay. N2 is the number of mole for solute. N1 is the number of mole of solvent. N2 is the number of mole of solute again. Okay. Again, we are simplifying it. Okay. Now W stands for weight. 1 for solvent weight, 2 for solute weight. M1 and M2 are for the molecular weight of the solute and solvent respectively. For 1 that is for solvent and 2 for solute. Okay. Now again we have to simplify. As the solute is present in a solution is very less compared to the solvent because it's a bulk. होता है ना, solvent बहुत bulk में रहता है, तो उससे बहुत कम होता है solute. So for that purpose we can ignore this one. ये जो solute का part है we can ignore that. So इसको simplify करके फिर क्या आएगा? P0 minus PS 5 by P0 is equal to W2 by M2 by W1 by M1. That means इधर से हम लोग कैरी कर रहे हैं. ओके, इसको फिर से मैं लिख रही हूँ उधर. प्रीवियसली इस चैप्टर का नाम होता था रिलेटिव मॉलिक्यूलर मास, मतलब हर कॉलिगेटिव प्रॉपर्टी से सॉल्यूट का मॉलिक्यूलर मास कैलकुलेट करना। ओके, सो वो ट्रेंड रह गया, लेकिन चैप्टर का नेम चेंज हो गया। सो वी हैव नाउ कैलकुलेट द मास ऑफ मॉलिक्यूलर मास ऑफ द सॉल्यूट विथ रिस्पेक्ट टू द रिलेटिव लोअरिंग ऑफ वेपर प्रेशर। इससे न्यूमेरिकल्स आता है, प्लीज ये फॉर्मूला रट्टा मार लेना, बिकॉज एग्जाम में अगर भूल जाओगे तो फिर क्या करोगे ना, इसका डिराइवेशन करने का कोई टाइम नहीं है एग्जाम में। ओके, our next colligative property is depression of freezing point और elevation in boiling point. Actually दोनों का, ये जो दोनों है ना, these two, इस दोनों का explanations are same. Wait a minute, हाँ. अभी ये दोनों क्या है? What is boiling and freezing? These two are phase change, है ना? Boiling में क्या होता है? To liquid to gas. So अगर ये जो दोनों phase change है, these two phase changes, temperature are fixed and it's mostly, actually it occurs in presence of atmospheric pressure. So whenever the vapor pressure of the liquid becomes equal to the atmospheric pressure, the phase change occurs. Actually that is the main thing. Okay, टेम्परेचर एक फैक्टर, प्रेशर अलग फैक्टर। टेम्परेचर तो फिक्स हो जाता है जब भी फेज चेंज होता है, फॉर एग्जांपल बॉइलिंग ऑफ वाटर 100 डिग्री सेल्सियस, इट इज फिक्स्ड। ओके, freezing of water 0 degree Celsius, temperature is fixed. But what about the pressure? When the vapor pressure of the water becomes equal to the atmospheric pressure, तब जाके क्या होता है, phase change start होता है। So अब भी जब ये solute ऐड हो रहा है solution में, non volatile solute, it makes the relative lowering of vapor pressure of the solution compared to the pure liquid. तो फिर क्या होगा, वेपर प्रेशर घट रहा है, मतलब क्या हो रहा है, प्रेशर घट रहा है। दैट मीन्स व्हाट हैपेंस, इसको इक्वल टू एटमॉस्फेरिक प्रेशर जाने के लिए यू हैव टू वेट, वी हैव टू चेंज द टेम्परेचर। सो फॉर दैट रीजन elevation of boiling point occurs and depression in freezing point occurs. Clear? For that reason, because relative lowering of vapor pressure घट रहा है, एटमॉस्फेरिक प्रेशर के साथ इक्वेट नहीं कर पा रहा है, तो टेम्परेचर बढ़ा के वेपर प्रेशर के साथ एटमॉस्फेरिक प्रेशर इक्वल करके हम लोग क्या कर रहे हैं कि हम लोग बॉइलिंग पॉइंट का, तो वो हम लोग ठीक है, तो बॉइलिंग पॉइंट एनहांस हो रहा है। लेकिन बॉइलिंग पॉइंट में क्या होता है, लिक्विड टू गैस। बट व्हाट अबाउट द फ्रीजिंग पॉइंट, उसमें क्या होता है, लिक्विड टू सॉलिड होता है ना। तो we cannot raise the temperature. What we can do, we can wait till the vapor pressure of the solution becomes equal to the atmospheric pressure. So for that the temperature is going down and the depression in freezing point occurs. Okay, so इसके लिए दो फॉर्मूला इधर लिखा हुआ है, that is delta TB is equal to KB into M. What is that? Now delta TB is elevation in boiling point. Mark my word, elevation in boiling point. That means this is the boiling point of solution and this is the boiling point of pure liquid. Water जो solvent होता है, ठीक है, that is proportional to molality of the solution. That is proportional to molality of the solution. Okay. Now the molality में मैंने क्या बोला था, molality means the number of moles present per 1000 gram of solvent. So we can write this is as delta TB, the difference. जैसे कि अगर सोडियम क्लोराइड हम लोग वाटर में डालते हैं तो उसका बॉइलिंग पॉइंट ज्यादा होता है ना, और उसको और कोई भी नॉन वोलेटाइल सॉल्यूट डाल देते तो टेम्परेचर हाई हो जाता है। सोचो 1 डिग्री 2 डिग्री 3 डिग्री, कभी कभी डेसिमल में भी हाई होता है, तो उसको भी काउंट करना पड़ता है। तो वही काउंट करके दैट इज कॉल्ड डेल्टा। दिस डेल्टा मीन्स द फाइनाइट चेंज विच वी कैन मेजर द डिफरेंस इक्वल टू Kb into m. This Kb is called proportionality constant. This is the molar elevation of boiling point, or this is also known as ebuloscopic constant. Ebuloscopic constant. Okay, and this is molality. This is when we are doing further simplification of the molality to this. Okay, molality to this. This is molality and this is the simplification form of molality. Okay, again, if we want to do this is the relative molecular mass of the solute compared to the elevation of boiling point at colligative property. Okay, and in case of depression and freezing point, the same B will be khali replaced by F. All parameters are same. The depression is freezing point is directly proportional to the molality of the solution. जब proportionality sign हटाओगे तो K पाएगा, that is known as molar depression constant और cryoscopic constant Kf, तो फिर वो आएगा और मोलालिटी को फिर से एक्सपैंड करोगे तो यही आएगा. ठीक है, तो डेल्टा टी एफ इज इक्वल टू केफ इंटू एम. लेकिन थोड़ा सा चेंज है. ओके, उसमें क्या चेंज है? डिप्रेशन इन फ्रीजिंग पॉइंट है ना, तो टीएफ नॉट प्योर से कम होगा सोल्यूशन में, इसीलिए टीएफ नॉट माइनस टीएफ सोल्यूशन दैट इज प्रोपोर्शनल टू एम. एफ एफ ओके. सो अनदर दो क्वालिटेटिव प्रॉपर्टीज का कॉन्सेप्ट इज नाउ डन. Only one has remained, that is osmotic pressure. Okay, now what is osmosis? Osmosis is very important thing. This is osmotic pressure. Now what is osmosis? This is semi-permeable membrane. Solution is this side, solvent is that side. Okay, in case of osmosis, from higher concentration of solvent going to the lower concentration of the solvent, that is solvent is coming from the outside and going to the solution through the semi-permeable membrane, that is called osmosis. अभी solution side में इतना pressure हो कि osmosis cease हो जाए, that is called osmotic pressure. And this osmotic pressure का क्या है? कुछ it depends upon few parameters which was described by Van 't Hoff. Scientist Van 't Hoff ने क्या बोला था? उन्होंने बोला था कि this pi is proportional to the concentration of the solution. This pi proportional to the absolute temperature of the solution. So इन दोनों को अगर combine करोगे तो pi proportional to CRT. This R is proportionality constant which has significance, that is universal gas constant. Pi is equal to CRT. when concentration and temperature both are changing, pi is equal to CRT. Okay, तो फिर से उसको सिंप्लीफाई, हर कॉलिगेटिव प्रॉपर्टी का मोटो ही क्या है कि रिलेटिव मॉलिक्यूलर मास ऑफ द सॉल्यूट कैलकुलेट करना. ओके, concentration means, acha, make a very basic concept, the difference between concentration and density. Density is the mass present per unit volume, concentration is the number of moles present per unit volume. बहुत लोग कंफ्यूज हो जाता है, व्हाट इज डेंसिटी, व्हाट इज कंसंट्रेशन. कंसंट्रेशन इज नंबर ऑफ मोल प्रेजेंट पर यूनिट वॉल्यूम. सो नंबर ऑफ मोल present per unit volume, again simplifying number of mole given weight by molecular weight, again that molecular weight को equate करने के लिए this is the simplification form in terms of osmotic pressure. This is also very important. Okay, now there are two solutions. दोनों का ऑस्मोटिक प्रेशर सेम होना कभी हो तो नहीं सकता है, कभी भी तो इनइक्वल हो सकता है. जिसका ऑस्मोटिक प्रेशर हायर होता है उसको क्या कहा जाता है, हाइपोटोनिक. जिसका लो होता है कहा जाता है हाइपरटोनिक. सॉरी, हाइपरटोनिक इज हायर एंड हाइपोटोनिक इज लोअर. ओके, और एक होता है सिनेरियो वेयर बोथ द सॉल्यूशन का osmotic pressures are same. That is called isotonic solution. That is very important. जो saline हम लोगों के blood में जाता है ना, that is isotonic. Okay, because अगर वो osmotic pressure कुछ इधर उधर blood से अलग हो जाए तो blood cell will be damaged, either plasmolysis or deplasmolysis. Either blood cells get shrink or it will burst. Okay, so इसीलिए some isotonic fluids can be injected through our veins. So what will happen with the isotonic? When pi 1 is equal to pi 2, this scenario is called isotonic. Okay, at what condition? At a fixed temperature. So what we know, if our pi is equal to CRT, है ना? So C1 R T1 is equal to C2 R T2. Okay, R cancelling out. At constant temperature, T1 is equal to T2. That means C1 is equal to C2. C मतलब number of mole present per unit volume. अब अगर वॉल्यूम भी इक्वल हो तो फिर क्या हो, N1 is equal to N2, है ना? Why? Because C is equal to N by V. तो अभी वॉल्यूम भी इक्वल, तो N1 is equal to N2. अभी N1 को सिंप्लीफाई करो, N2 को सिंप्लीफाई करो, that will be W1 by M1 is equal to W2 by M2. This is very 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 important. For isotonic solution, W1 by W2, W1 by M1 is equal to W2 by M2. इससे न्यूमेरिकल आता है. एक का मॉलिक्यूलर वेट बोल दिया गया है कि दूसरे का मॉलिक्यूलर वेट कैलकुलेट करो, एक का अमाउंट बोल दिया कि दूसरे का परसेंटेज स्ट्रेंथ कैलकुलेट करो. सो दिस कॉन्सेप्ट शुड बी वेरी क्लियर. आइसोटोनिक, व्हेन आइसोटोनिक सॉल्यूशन इज दैट मींस पाई 1 इज इक्वल टू पाई 2, दोनों का ऑस्मोटिक प्रेशर सेम, वॉल्यूम कांस्टेंट, टेम्परेचर कांस्टेंट. देन क्या हो जाता है, W1 by M1 is equal to W2 by M2. Okay, next slide. Oh, here is a numerical. Okay, so you just study or you just read it. Okay, and give me 2 minutes time. I'm coming back. Okay. Okay, welcome back, students. I have given you a problem. Now here is the solution of that. This is actually based on the strength of solution. Today I have given you, I have tried to give you the problem on every topic. Okay, so this is one of the strength of solution. It is noted that 68% nitric acid by mass is there, by mass. Okay, and density of the solution is given. We have to calculate the molarity. Fine. So for that purpose, at first we have density, and for molarity calculation earlier I have told you for 1000 ml solution. So for 1000 ml solution, the volume is 1000 ml here. Okay. So density is this, volume is this. We know the mass is equal to density into volume. We got that. Okay. Clear? Now, what is the percentage of the nitric acid by mass? That is 68%. So, how much nitric acid is there? 1504 into 68% ग्राम. ना अभी इसमें जितना वेट है उसको अगर हम लोग क्या करेंगे, मॉलिक्यूलर वेट ऑफ नाइट्रिक एसिड से डिवाइड करेंगे, then we will get the number of moles. Like that is X. We have taken. You have to do the calculation. Okay. So that is the amount of nitric acid present in 1000 ml. Okay. This is the amount of, this is the total weight volume of the 1000 ml solution. This is the amount of nitric acid present. Now this is divided by the molecular weight of the nitric acid. We are getting the number of nitric acid present. तो इतना नाइट्रिक एसिड के नंबर ऑफ मोल किसमें है? 1000 ml वॉल्यूम में ही तो है. So that is the molarity. It's very easy. Okay. So our next problem. Now, a solution of lactose containing 8.45 gram of lactose in 100 gram of water. What I have said earlier कि अगर कोई भी किसी मतलब solvent के लिए हम लोग क्या करेंगे, 1, solute के लिए 2. तो फिर W2 is our solute, that is lactose, given 8.45 gram. Water W1 is equal to 100 gram. Fine. अभी solution का क्या दिया हुआ है? Vapor pressure of the solution is this. So this is solution का vapor pressure. Okay. Now pure form का क्या है? Pure form. Okay. इसका vapor pressure is this. So this. So what was our formula? P naught minus PS divided by, sorry, P naught is equal to W2 by M2 divided by W1 by M1. We have simplified earlier, and that M2 is for molecular weight of lactose and M1 is molecular weight of water. Okay, and this is for lactose and this is for water. So we know the molecular weight of water, that is 18. So we can calculate this one very easily. Have a screenshot. The next one. This one is very interesting. It's from NCERT. Previous questions were few from NCERT, few from CBSE, ISC, and this is from NCERT. This is for ideal solution. The benzene and toluene mixture, दोनों का pure form में BZ is for benzene, TOL for toluene. Okay. So this is the pure form का vapor pressure and this is for also for pure form का vapor pressure. And क्या बोला है कि 80 gram of benzene is with 100 gram of toluene. So at first we have to calculate the number of moles of benzene and toluene. Benzene का molecular weight calculate करो C6H6 और toluene का है C6H5CH3. Okay, or given weight by molecular weight करके you will get the number of moles. From number of moles you can calculate mole fraction दोनों का. ठीक है. So after that mole fraction calculation we already studied this solution. Solution का vapor pressure, ideal solution का vapor pressure क्या होता है कि दोनों component का जो है individual vapor pressure, that is pure form का vapor pressure multiplied by the mole fraction again for the another one, this and this. Okay, दोनों को add करके you will get the solution का. अभी question क्या है? Question है कि Mole fraction of benzene in vapor phase. Okay, not in solution. So for vapor phase, what was the formula? कि individual in ये जो होगा उसके साथ पूरा solution को divide करोगे तो you will get that. This is the simplest steps you have to follow, and this is fixed. No science, no technology behind this. Okay, only the steps you have to follow. Just go through these steps, you will get the solution. Okay. Again, I'm scrolling. Check it out. Okay. Next problem. Now this one is very important. This is abnormal colligative property. Why this abnormal? Because first we have started with pure solution, gas in liquid, liquid in liquid, non-volatile, volatile solute in liquid, volatile liquid in liquid, non-volatile solute in liquid. Now we are going deeper. If the solute dissociates or associates, then what will happen? If solute dissociates, that means one solute will impart different number of particles and different effect on colligative properties, because we know that colligative properties depends on the number of particles, not the nature of the particle. And if the solute associates, then number of particles will decrease. That means effect will decrease. Okay, so for that measurement, here is the abnormal colligative properties, and that is the Van 't Hoff factor I. This I is observed colligative property divided by theoretical colligative property. This is very important. Okay, and from this I we can calculate the degree of association and degree of dissociation. What is that? Alpha. This is degree of dissociation, that is equal to I minus 1 by n minus 1. I is Van 't Hoff factor, n is the number of particles जितना में एक molecule dissociate हो रहा है. For example, sodium chloride. Okay, so sodium chloride will dissociate into two ions, one sodium plus and one Cl minus. That means one sodium chloride molecule will impart of two particles, one sodium, one Cl. For example, K2SO4, दो potassium, एक sulfate, मतलब तीन particle. Okay, so this is our value. Achha, sometimes anyone numerator or denominator be negative, ignore the sign, take the value. Ignore the sign, take the value. Okay, x degree of association. Achha, what do you mean by association? Sorry, association means when or more than two molecules will combine, actually will unite together, which is called dimer, trimer. Okay, that is called degree of association. That's why it is 1 by n. Here it is n number of particle में dissociate कर रहा है. ये क्या हो रहा है? दो तीन मॉलिक्यूल इम्पार्ट होके एक मॉलिक्यूल का इफेक्ट दे रहा है, कंबाइन होके. That's why this is 1 by n minus 1. Okay, so you can calculate the association or dissociation. For strong electrolyte, प्लीज रिमेंबर, अब कभी भी किसी न्यूमेरिकल, फॉर एग्जाम टिप्स, किसी भी न्यूमेरिकल में ऐसा लिखा हुआ है कि कंप्लीट डिसोसिएशन, दैट मींस अल्फा इज 1. दैट मींस अल्फा इज 1. फॉर कंप्लीट डिसोसिएशन अल्फा इज 1. देन जो आई का वैल्यू होता है ना, दैट बिकम्स इक्वल टू द एन. Van 't Hoff factor becomes equal to the number of particles जितना में वो मॉलिक्यूल डिसोसिएट होता है. ओके, फॉर कंप्लीट डिसोसिएशन बहुत सारा PYQ या पैटर्न क्वेश्चन में ऐसा लिखा रहता है कि सॉरी द सॉल्यूट dissociates completely. That means alpha is 1. A small problem on it. A 0.01 molar aqueous solution. That means this is molality. Okay. Next, given. Okay, this is the depression in freezing point. Most of the numericals in PYQ on the base of depression of freezing point. Okay, I don't know why. So that is जो क्वेश्चन में दिया रहेगा, that is observed. और जो तुमको सारे जो कैलकुलेशन से थियोरेटिकल फॉर्मूला डाल के जो कैलकुलेट तुम कर रहे हो, दैट इज होता है थियोरेटिकल. ओके, सो दिस इज ऑब्जर्व. ये जो वैल्यू दिया है KF और ये M, इससे हम लोग क्या निकालेंगे? थियोरेटिकल. ओके, सो वी आर गेटिंग द random factor observed by theoretical. Right? Now this is x is equal to what we know. Sorry, this is dissociation. This is alpha is equal to I minus 1 by n minus 1. Now what will be n? This is very important. Aluminium trichloride. That means 1 aluminium 3 plus iron 3 Cl minus. That means n is equal to 4. Okay. Aluminium trichloride. 1 aluminium 3 chlorine. That means 1 molecule dissociates into 4 ions. So you will get 4 particles. Okay. And from that I from formula observed by theoretical and n from this calculation, then you can easily calculate the degree of dissociation. And जो ये आएगा ना, अगर ये 0.28 0.34 ऐसा कुछ आता है ना, तो multiply it with 100. That will be your 100% in terms of percent dissociation. Okay, because question is in percent dissociation. ये जो value आएगा उसको into 100 करो. Now this is our last portion, actual exam tips. How you have to study this chapter. This chapter carries mostly 4 to 6 marks in CBSE or ISC. In regional state boards, its impact is also very high. So, firstly, you have to study a book of your choice. What topic I have learned to you, I have teachers I have taught to you today. You have to learn that from any book which you like first. Second, you have to remember all the formula. It is very common. You have to remember all the formula because in exam there is no time to derivation. And that formula का जो implication जो numericals होता है, how to imply that, you have to know that also. That concept should be very clear. And to have that concept and build that concept, please come to us. Whenever you revise, above our mentorship, we will revise. We will take mock tests. We will mock test series. We will give assessment. Lots of things. Have our mentorship, okay? And read the chapter. Remember the formula, concept, please, and do take care of your health and mental status also because time is ticking. You have to take care yourself also. Otherwise, health is wealth. हेल्थ का ख्याल रखो तो हेल्थ सबका ख्याल रखता है. ठीक है, तो पढ़ाई भी ठीक से करो. थैंक यू.